Welcome to A-Level and AP Physics. In today's lesson, we will discuss some very important concepts and typical type of questions on polarization for our paper 1 exam. My main goal of this video is to make sure you have clear understanding of polarization and you can handle questions on polarization with confidence. So let's try to understand polarization by solving past paper questions. First of all, let's try to understand some basic concepts about polarization, and then we will use these concepts to answer past paper questions. First of all, we will try to understand a little bit about EM waves. Electromagnetic waves. EM means electromagnetic. E for electric field means electromagnetic waves. They consist of oscillating electric field and also oscillating magnetic field. So simply we can write down here oscillating magnetic field. An electric field for unpolarized light, it can oscillate in any plane. So that's the reason we call the light is unpolarized. If you look at this one, this light is unpolarized. Means in this case, the electric field can oscillate in any direction. So we call this one is unpolarized because electric field can oscillate in any possible plane. Now, if you go to next one, we place a polarizer in front of unpolarized light. Means when unpolarized light pass through this polarizer, the intensity of this one decreases to half. So you can see the intensity of this one is I naught, and after passing through this one, this light has been polarized. So you can see this transmission axis is vertically, so this light is vertically polarized. So simply we will say this light is vertically polarized. So you also need to understand what is vertically polarized. Means only vertical components can pass through this polarizer. And the second thing you need to understand, any unpolarized light, when it passes through any polarizer at any angle, means angle of transmission axis can be any angle. For example, we have this transmission axis. If the transmission axis was like this, again, if you pass this unpolarized light through this polarizer, again intensity will be half. So you need to understand unpolarized light, when it passes through first polarizer, always intensity decreases to half. So this is the one point we have to be very clear. Now let's look at the second now. You see we have an other polarizer. So in this case we are saying this is analyzer. So this is an other polarizer. But now in this case you need to understand this light is vertically polarized, means this is vertically polarized. And the angle between vertically polarized light and transmission axis, in this case this angle is theta here. And the light coming out of this one has intensity that is equal to 1 by 2 I naught. So this intensity, you need to understand, this is 1 by 2 I naught intensity before analyzer. So the intensity after analyzer, this is I, and this is how we can find out. Let's try to understand a little bit more about Malice's law, because this is based on Malice's law. So you need to understand Malice's law for this purpose. In this case, I will say I is equal to, this is Malice's law, I is equal to I naught times cosine square theta. This I is intensity of transmitted light. So this is intensity of transmitted light. So you have to be clear about these terms. So this is intensity of transmitted light. And I naught, this is intensity of incident light. Later I will explain what exactly it means by incident. Intensity of incident light. So here is incident light. And theta, this is the angle between, so I will be writing here, angle between polarized light. So we will say angle between polarized light and transmission axis. And transmission transmission axis. So here is transmission axis. Angle between transmission axis and polarized means that, so this light is vertically polarized, so simply you can say this is vertically polarized. So if we draw them together, so this is vertically polarized light and this is transmission axis. This one is transmission axis. So the angle between them, this is the angle between polarized light and transmission axis. Now let's try to understand what is meant by incident light. In this case, I naught by 2, this is the incident light. So we can simply write on here, this one is the incident light. So I naught is the intensity of incident light. Now we need to understand transmitted light. In this case, this is the transmitted beam, or you can say this is transmitted light. So the intensity of this one, in this case, we are saying is I. So if you look at this equation now simply you can understand here, this is intensity of transmitted light. So again, we can write on here to master this concept. We can say this is intensity of transmitted light. And this is intensity, this is intensity of incident light. So this is incident light. So this one is incident light and theta is the angle between polarized light. So this is angle between polarized light, means between vertically polarized light and transmission axis. So we can say angle between polarized light, very important. So this is the angle between polarized light and transmission axis. So transmission axis. So that's all what we need to understand about Malus' law. Later we will apply this law and this concept will be very clear to you. We also need to understand one more point. What kind of waves can be polarized? So we can polarize transverse waves. Transverse waves like electromagnetic waves, they can be polarized. So they can be polarized, but longitudinal waves cannot be polarized because longitudinal waves only oscillate in one plane. So longitudinal waves like sound waves cannot be polarized because they just oscillate in one plane. Our waves travel along one direction only. That's the reason longitudinal waves cannot be polarized. Let's move on to next now. For question number 1, it is given to us unpolarized light is incident on a polarizer as indicated above. You can see here this light is unpolarized light. It is incident on a polarizer. It is also given to us, then it falls on an analyzer. So here we have analyzer whose transmission axis is at an angle theta to the vertical. Which graph depicts the transmitted intensity as theta is changed from 0 to 360 degrees. Now first thing we need to understand where we can use Malus' law. Malus' law you can only use here. So the Malus' law can only be used here when the light is polarized. So we will write down Malus' law. Means I transmitted. So that means we will write. So Malus' law simply tells us intensity of transmitted light is equal to intensity of incident light times cosine square theta. Now in this case we need to understand if cosine, for example, if theta is equal to 90 degrees, what is cosine of theta? That one will be equal to 0. So cosine square theta also will be equal to 0 if theta is 90. We also need to understand if theta is equal to 270 degrees. So here we can also write down degrees. So the cosine of 270 degrees will be equal to 0. And cosine square of 270 degrees also will be equal to 0. Now based on this one, we can find out our answer. Now the first thing also we can understand if theta, for example, this is equal to 0 degrees. So the cosine of 0 degrees, this is 1, or simply we can say it will be maximum. And if theta is equal to 180 degrees, cosine of 180 degrees means the magnitude, it is also maximum, but it will be, answer will be negative. So I will be writing here negative. That if you take the square of that, cosine square of 180 degrees, this again will be positive because negative negative is positive. Maximum. And we also need to understand theta, if it is 360 degrees, cosine of 360 degrees, this is maximum, and cosine square of 360 degrees is also maximum value, or you can say 1 square is 1. So this is how you can understand to answer this question. Now first thing we need to understand is that the shape of the graph, it has to be a cosine function. So it means A is not answer, C is not answer, answer can be B, or answer can be D. First of all, if you look at D now, it is telling us when angle is 0 degrees, this is minimum, so this one is not possible. But if you look at B graph, when angle is 0 degrees, intensity of transmitted light is maximum, so this is right. And when angle is 180 degrees, intensity of transmitted light is maximum, so this is also right. And when angle is 360 degrees, intensity of transmitted light is maximum, this is also true. We can also check 90 degrees to 70 degrees, it has to be minimum. So our answer for this question is B. You also need to understand how to sketch this graph, or you need to understand how to identify this graph. For this question, it is given to us a light beam of intensity I0 is polarized parallel to the transmission axis of a single polarizing filter. Through what angle theta should the polarizer be rotated to reduce the transmitted intensity I to I0 by 5? I0 by 5. So if this intensity is I0, intensity of this light, it has to be equal to I0 by 5. So this is what is given to us. So this is a kind of typical question about Malus' law, means based on Malus' law. So first of all, let's try to write down Malus' law. I transmitted. So I will be writing here I transmitted. This should be equal to I incident. So we can again write down this is I incident times cosine square theta, angle between polarized light and transmission axis. For this question, it is given to us I incident is equal to I naught. So this is I incident, this is I naught, and I transmitted has to be equal to I naught by 5. So this is I incident times cosine square of theta. Now in this case, simply you can see I naught we can cancel with I naught. So from here we can say that cosine square theta, this is equal to 1 over 5. If we take square root on both sides, we can say cosine of theta is equal to 1 over root of 5. So theta from here will be equal to cosine inverse of 1 over root of 5. So if we solve this, our answer will be 63.4 degrees. So the answer for this question is A. So this is the right answer. And this is how you need to apply Malus' law. For question number 27, we need to understand what kind of waves can be polarized. Only transverse waves can be polarized, as we have discussed before. Why only transverse waves can be polarized? The reason is that vibration of particles, so simply we can say vibrations of particles and wave travel, propagation of wave, they are at angle of 90 degree to each other. Propagation of wave, they are at angle of 90 degree to each other. So we can simply write down they are perpendicular to each other. That's the reason transverse waves can be polarized, because vibrations can be at different orientations, so we can polarize them. Vibrations can be at different orientation. That's the reason we can polarize them. So simply we can say at different orientations. So we can polarize transverse waves, but we cannot polarize longitudinal waves, because vibrations of particles and propagation of wave, they are in the same direction. Propagation of wave, they are in the same direction. Propagation of wave are in the same direction, or we can say they are parallel to each other. That's the reason longitudinal waves cannot be polarized. Electromagnetic waves can be polarized because these are type of transverse waves. They can be polarized. So know they can be polarized, but sound cannot be polarized because sound is longitudinal wave. It cannot be polarized because vibrations and propagation of wave, they are parallel to each other. So the answer is transverse wave. Answer is not B because electromagnetic wave is one example of transverse wave. So that's the reason answer is not B. Answer is D for this one. For this question, it is given to us two polarizers have polarizing axes that make an angle of 30 degrees to each other. So simply you can see here we have first polarizer, its transmission axis is here. So it has transmission axis is vertical. And the second polarizer has transmission axis. So this is transmission axis of second polarizer. Now if we place the first one on top of the second one, we can simply draw here. So this is vertical transmission axis, and the angle between these two transmission axes is given. This angle is 30 degrees. Now question is asking us to find out unpolarized light of intensity I1. So this is unpolarized light. Simply we can draw these arrows here, means the electric field is oscillating in different planes. So we can draw some arrows here. So this is telling us this is unpolarized light, and intensity of this one is given I1 is incident on the first polarizer, so that light of intensity I2 emerges from the second polarizer. So the intensity of this light is I2. Now we need to find out what is the intensity of light when it passes through first polarizer. So that one has to be half of the first incident, means half of the intensity of unpolarized light. So we will say this is I1 by 2. Question is asking us, we need to find out what is the ratio of I1 to I2. So this is what we need to find out. But it is also given to us that cosine of 30 degrees is equal to root of 3 by 2. Now simply we have to use Males's law. So first of all, let's try to write down Males's law. So I transmitted has to be equal to I incident times cosine of theta, square of cosine of theta, between, in this case means polarized light and transmission axis, means 30 degrees. So I incident, we have, this is here I incident, this is I1 by 2. So we can say this is I1 by 2, and I transmitted, this one is I2, and cosine of theta is given, cosine of theta, this is 30 degrees, square of this. Now we can simplify this. We can write down, this will be I1 by 2, and cosine of 30 degrees is given, this is root of 3 by 2, and square of this one. We can further simplify. We can say I2 is equal to I1 divided by 2, and this is 3 divided by 4. Now question is asking us to find the ratio of I1 by I2. Now if we divide this side by I2, so we can cancel I2 by I2. We can also divide on this side. So I2 we can cancel with I2. So we left with 1 here. So now I can write on here. So this is 1 times 8 divided by 3. This is equal to I1 by I2. So simply you can say in this case I1 by I2. This is 8 by 3. So the answer is D for this question. For question number 26, we need to find out which statement about a light wave and a sound wave is correct. First thing we need to understand, light waves are transverse waves. So we can write on here, light waves are transverse waves and sound waves are longitudinal waves. So we can write on here, longitudinal waves. Now for option A, it is given to us both can be polarized. So only transverse waves can be polarized, but longitudinal waves cannot be polarized. So A is not correct option. Both can travel through free space. Transverse waves means electromagnetic waves. They can travel through space, light waves, but sound waves cannot travel through free space. They need medium. So sound waves, they need medium. So option B is also incorrect. So this is also incorrect. If you look at option C, it is given to us Both have frequency that is inversely proportional to wavelength. And this one is right because frequency of wave is equal to V over lambda. So from here we can see frequency is inversely proportional to wavelength. So option C is correct. But if you look at option D, it is given to us both have intensity proportional to amplitude. But intensity of a wave is proportional to amplitude squared. So option D is also incorrect. So the answer for this question is C. For this question, it is given to us when plane polarized light of amplitude A is passed through a polarizing filter as shown in this figure, the amplitude of the light emerging is A cosine theta. So this is the amplitude of emerging light. It is also given to us the intensity of the initial beam is I. Question is asking us what is the intensity of the emerging light when theta is 60 degrees. Let's say intensity of this emerging light is I1. Now we need to find out what is value of I1 in terms of I. This question is about intensity and amplitude. We need to understand for any wave, intensity is directly proportional to amplitude squared. We can also say intensity over amplitude squared. This is constant, means the ratio between these two, this stays constant. It simply means that when I decreases, means the intensity of the light decreases, amplitude also decreases. But the ratio between these two, it remains constant. Now we can use this principle and we can try to find out value of I1. So simply we can say I over A squared. This one has to be equal to I1 divided by the amplitude of I1, means the amplitude of emerging light. Amplitude of emerging light is A cosine of theta. So we can say this is square. Now if we simplify this, we can say I over A square. This is equal to I1 over A square cosine square theta. Now we can cancel A square with A square. From here we can find out I1 is equal to I times cosine square theta. But theta in this case is given is 60 degrees. So simply we can plug in values of theta. So we can say cosine of 60 degrees squared. So this is here. But we need to understand cosine of 60 degrees. This is equal to 1 by 2. Or simply we can say this is equal to 0.5. So we can replace now cosine 60 with 0.5. So we can say 0.5 squared. Now if we simplify this one, we will get 0.250 times I. So this is value of I1. So the answer for this question is A. This question is also based on Males's law. For this question, it is given to us an unpolarized light is incident on a polarizer. The light transmitted by the first polarizer is then incident on a second polarizer. The polarizing or transmission axis of the second polarizer is 30 degrees to that of the first. The intensity incident on the first polarizer is I. On the first polarizer, incident means this one is I. So we can say intensity of transmitted light from the first polarizer, we will say this one is I1. And the intensity of light transmitted from the second polarizer is I2. This figure is actually not for this question. So please, this figure is different actually. I'm using this one to give you clear understanding of this question. This figure is not part of this question. Not part of this question, so you have to be clear. I'm using this one just to make it clear to you so you can have better understanding. So this is I and this is I1 and this is I2. We need to find out what is the intensity emerging from the second polarizer. Means we need to find out what is I2. So this is what we need to find out. So again we will use Males's law. So we will use Males's law here. So we will be using Males's law here. Now simply we need to use Males's law. According to Males's law, I transmitted is equal to I incident times cosine square theta. In this case, theta is equal to 30 degrees. So angle is 30 degrees. Means this angle, this is equal to 30 degrees. So this is our I transmitted, and this one is I incident on this polarizer. So I will be writing here I2. This will be equal to I1 cosine of 30 degrees, square of that. Now we also need to understand cosine of 30 degrees. This is equal to root of 3 by 2. So simply we can replace here cosine of 30 degrees. We can say this is root of 3 by 2 square. So simply we can say in this case I2 is equal to I1 3 divided by 4. But we need to understand this is I and this is I1, and I1 is equal to I by 2 because this is I and this is I1. So when unpolarized light, it passes through any filter, its intensity decreases to half. So I1 is equal to I by 2 because our answer has to be in terms of Y. So now simply we can replace I1 with I by 2. So here we need to multiply by 3 by 4. So here we got this is 3I divided by 8. So from here we can find out I2, this is equal to 3I divided by 8. So our answer for this question is 0.38 times I. So this is our final answer. So answer is B. So B is the correct option.